Most atoms don't ride solo. Instead, they bond with other atoms. Now, bonds can form between atoms of the same element, or atoms of different elements. You've probably imagined bonding as a tug of war. If one atom is really strong, it can pull one or more electrons off another atom. Then you end up with one negatively charged ion and one positively charged ion. And the attraction between these opposite charges is called an ionic bond. Table salt, sodium chloride, is held together by ionic bonds. Every atom of sodium gives up one electron to every atom of chlorine. Ions are formed, and those ions arrange themselves in a 3D grid called a lattice, in which every sodium ion is bonded to 6 chloride ions, and every chloride ion is bonded to 6 sodium ions. The chlorine atoms never give the sodium atoms their electrons back. If one atom doesn't completely overwhelm the other, they can actually share each other's electrons. This is like a potluck, where you and a friend each bring a dish, and then both of you share both dishes. Each atom is attracted to the shared electrons in between them, and this attraction is called a covalent bond.
2 chlorine atoms share a pair of electrons to form a chlorine molecule. The chlorine atoms are linked by a single covalent bond. Oxygen atoms have 6 valence electrons. When 2 oxygen atoms combine to form an oxygen molecule, they share 2 electron pairs to form a double bond. In this way, both atoms achieve the stable configuration of neon.
Since every nitrogen atom has 5 valence electrons, they both share 3 of them when combining with each other. They form a triple bond. In the nitrogen molecule, both atoms have the stable electron configuration of neon. A sigma covalent bond is formed by the overlapping of 2 s orbitals, or one s and one p orbital, or 2 p orbitals orientated along a common axis.
Van der Waals forces are forces of attraction between molecules that are very close together. These forces between molecules are much weaker than the chemical bonds between the atoms holding a molecule together. Molecules are electrically neutral because they have equal numbers of positively charged protons in the nucleus and negatively charged electrons outside the nucleus. In addition, some molecules are also polar. Polar molecules have permanent poles of electrical charge like a magnet because the electrons are unevenly distributed around the molecule. Let's look at an example of a polar molecule: water. When a water molecule forms, both hydrogen atoms bond with the oxygen atom by sharing their electrons with the oxygen atom. However, the electrons aren't shared equally between the atoms because the oxygen atom attracts the electrons more strongly than hydrogen. As a result, a partial negative charge develops around oxygen because there are more negatively charged electrons around the oxygen side of the molecule. This unequal sharing of electrons creates opposing poles of electrical charge on either side of the 2 bonds that hold the atoms together. Because of the opposite poles, these bonds are called polar covalent bonds. And since a water molecule is angled or bent with both of the hydrogen atoms on one side and the oxygen atoms on the other side, the molecule as a whole also has opposite poles and therefore is referred to as a polar molecule. Now, when polar molecules are near each other, a van der Waals force of attraction between the molecules occurs because of their oppositely charged poles. In this example, the attraction of a polar molecule's negative pole to the positive pole around hydrogen atoms in water is a particularly strong type of van der Waals force called a hydrogen bond.